Function or not a function? That's our discussion today. I'm Brandon Clayton, the Algebra Guy, and today we're going to determine what is a function, what's not a function. Very simple. Should be pretty easy to pick up. Most students do pretty well here, so I anticipate you doing the same. The lesson is, the TEK is 12A. Decide whether relations represented verbally, tabularly, graphically, symbolically define a function. So we're going to look at different stimuli, if you will, to determine if something's a function or not. But first, let's start here. I got a little soda machine, a fountain machine, I think it's called, and we label them A, B, C, D. Doesn't matter what actual drink is there. But what is a function? A relationship or expression by where each input has a single output. Each input has a single output. So that's very important for it to be a function. And let me illustrate what I mean. So if you press the A button, the soda, you want a soda A, you should get some kind of drink, right? So let's call that, little a. And if you press B, I can't see that well. Let's do, okay, we'll do that one. So we'll do A, B, C, and D. Let's say we get the little letters, right? So you press this button, you get little a. Yay, that's what I wanted. You press B, you get little b. Yay. So you're happy, right? So that's the way a function works. You have an input. These are all right here. Consider your input. And what you're getting out right here, all these is your output. So whatever input you put there, you should get a particular output. Now that's a function. Here's what makes it not a function. What if you came along and when you pressed A, you got A sometimes, and then sometimes you got B. Sometimes you press the A button and you got Sprite, and sometimes you press the A button and you got Coca-Cola. Sometimes you press it and you got Pepsi or Big Red. Sometimes, and you'll be frustrated. So the fact that you're frustrated says this is not a function. What does that look like mathematically? Well, if you have a simple equation like this, is this a function? Well, if I put in a particular x value, 0, let's say this is a table here, I put 0 in, what do I get for y? This is going to make that 1. If I put 1 here, that'd be 2 times 1 is 2, plus 1 is 3. If I put 2 here, then that'd be 5. So notice that every x value gives a particular y value, some output. Well, you can't put 0 in and get a 1, and put a 0 in sometimes and get a 3. That just doesn't even make sense. That's why we say it's not a function. So that's really what we're after when we're asking ourselves, is this a function or not? So let's practice a little bit. What if you had a graph? How do you determine whether it's a function? Well, there's something cool called a vertical line test. Now, this is not necessarily a trick, but it'll make sense from what we just talked about. You could draw a vertical line, and you can draw this literally, or just, imagine it. If you draw a vertical line through that graph, and so this line right here is our graph that we're looking at, our function, does it cross more than once? So every time, so there's only one point of crossing right here. There's a point of crossing right here, a point of crossing here. So there's only one point it crosses. So this we would call a function. Because everywhere you draw a vertical line, the infinite number of vertical lines, is only going to cross that line once. What about this one here? So if I draw a vertical line, look at what happens. Right here it crosses twice, right? These two places. So this, just because of those points, is not a function. And again, we'll go here. If we draw here, look at what happens. Vertical line test. There's all kinds of problems with the circle. This can't be a function, because for this x value right here, it's going to yield two different y values. It can be this number or it can be this number, and it just can't happen that way to be a function. So this is not a function. I'm just going to put not. I'll put not function. Make sure there's no confusion. Not function. All right, so what about this? So if I draw a point through there, yep, that's good. No others. This is good. No, it's kind of crooked, but I'll go with that. So there we go. Vertical line. So you can see, you can do this mentally. Some students like to use a pencil or a straight edge just to kind of get a visual. But once you see it, it's hard to unsee it. You'll kind of visualize that this it's not going to pass, right? You'll say, well, this is 2 points it's crossing right there on that vertical line, so this is not a function. This is a function. What do you think this one is? Good. I hope you're saying function, right? So function, why? Because you can have vertical lines go through here, and it's not going to cross but one time on each place on that graph. So this one, we call it a function. And what about our last one here? Function or not a function? I still hope you're saying function. Good. Function. Because look, we can cross infinite number of places, but it's only going to cross one. Even though it's a wavy, curvy line, and you may think, oh, that looks kind of weird. Something's going to cross twice, but it doesn't. All right, continue our practice. What if you have a relation like this table or one of these guys here? How do you handle that? So let's start with a relation. So you're definitely going to, I'm almost sure you're going to see one of these. The easiest thing to do is start just by looking at your x values. Just look at your x values. Are they repeating? If they're not repeating, it's a function. You don't have to even worry about it, because it's only when you have an x value that has 2 different y values that makes it not a function. So -2, 2, 3, 4, 5. So this is good. This is a function. This is a function. What about this one? Let's look at the x. -3, -2, 1, -3, 0. Oh, I saw -3 come up twice. Now that's fine if they're giving you the same output. But are they? Nope. One has a 2, one has a 1. That is not going to work, buddy, because you can't push -3 on that soda machine and sometimes get 2 and sometimes get 1. So we're going to say this is not a function. See how simple that is? And this is algebra. All right, so -2, same thing for a table. You're going to just look at these x values here. Is anything repeating? -2, -1, 5, 4. Nope, nothing's repeating. So without even looking over here, I already know this is a function. There's nothing repeating. As far as I can see on this table, this is a function. What about here? I do see -3s repeating. All right, so now let's check the y. They have different y's for to be a function. This cannot happen. So this is not a function. And sometimes you may see this matrix looking deal here. So this is saying I have a 6 that going to a 3 and a 6 that's going to a 5. Can that x value have 2 outputs, 2 different outputs? No. So this cannot be a function. Not a function. Regardless of what's happening with the 7 and 8, if one of those is off, the whole thing is not a function. And I see again this 6. I don't know what's going on with this 6 here. 5 and 10. You can't do that, Mr. 6. So it's not a function. You just got to talk to Mr. 6 like that and say, hey, you can't do that, man. Not a function. All right, so we're going to erase all that. That's how simple it is. How does it look on the STAR test? So let's jump and see a couple of problems for how it came up on the STAR test. Which set of ordered pairs represents y as a function of x? See, just like the same, get 100 on this. What's the correct answer? Go ahead and pick that right answer on your paper or on my screen. All right, first I'm just going to glance through and look for what? All right, I'm going to look for the x values. Are any of these repeating? No. So this says which set of ordered pairs represents y as a function. So this one's looking pretty good. -9, that looks like it's representing a function. I got -1, 4, -7. Oh, I got -1 repeating twice with different, nope, that can't be it. 3, -4, oh, I got 3 repeating twice with different y's. Nope, that can't be it. 5, 2, 1, 2. I got 2's repeating twice with different y's. Nope. So our only clear answer is A, 100%. Everyone should get 100% just to embarrass the STAR test on this one and say, wow, the kids are not having any issues with this. Now, this tends to be one of the easier topics for students, and don't miss any points losing something like that, missing something like that. What about the graph? Which one of these is a function? Remember our test? It's called the what? Vertical line test. So that's where you can draw a vertical line and see. It says which one does not. So remember that does not represent is what we're looking for. So this is, right? Because I can pass through here and it only pass through once. That's looking kind of suspect because 1, 2, 3. I mean, this thing just keeps going. This is not a function. However, this can be represented as a function. It's only passing through once. It seems like this may not, but look, it's going to keep going out that way slowly. Don't worry about that. This is obviously a function as well. This one is the clear choice. Can't be right. Not a function. Watch that wording in there. Which representation does not, okay, there it is again, does not show a y as a function. So we're looking for x's that repeat. So this one is fine, right? Look, these x's do not repeat. -2, -1, and they go straight across the different outputs. 2, 5, 7, 8. This is good. Nothing's repeating. And by the way, even if the y's are repeating, so you can pick, you could, if we went back to our soda machine example, and we had A, B, C. It's okay that A gave us A and B gave us A and C gave us A. That's okay, because the same button can give you two different answers, but all three buttons can give you the same answer. And how would that look on a graph? That'll just simply look like a straight line going across horizontally. So that does pass the vertical line test. So, all right, so let's do this from -1, 0, 2, 7. Those are all different. That looks good. And vertical line test this one, and look what happens. Vertical line, it doesn't pass, it doesn't pass. I mean, this one is all over the place. That is not a function, so we're going to have to go with that one. Did we do it? Absolutely. So we accomplished our objective. We figured out how to define what's a function or not a function. Skill 12A on the Algebra 1 TEAC. Hey, my name is Brandon Clayton, the Algebra Guy, and I will see you next lesson.